There is a paper out of April 2026 making a claim that sounds almost recursive. An agent, running entirely on frozen model weights, rewriting its own skill library at deployment time. To be precise about the mechanics, the system is not fine-tuning. It is not retraining the base model. The agent is continually constructing, editing, and expanding executable code artifacts based purely on its own runtime experience. This chart compares agent baselines against this self-rewriting architecture. You are looking at a 20-point jump on the hardest benchmarks, scoring 66% versus 52.3% on GAIA and 38.7% versus 17.9% on Humanity's last exam. Those numbers are real, but that top-line headline hides a highly specific constraint. The mechanism that generates this performance only works under strict environmental conditions. Welcome to Bearded AI Guy. I'm analyzing the work of the human architect, unpacking one of the clearest examples of the agent designs agent paradigm to land in 2026, a system called Memento-Skills. The 2026 agent stack is converging on a single engineering bottleneck. If your base model is completely frozen and training runs are too expensive to iterate constantly, you have to find a new place to store continuous learning. Memento answers this by shifting the capability burden entirely out of the internal neural weights. Instead, it places it into a localized external library of editable skill artifacts that the agent manages itself. The agent accumulates experience by saving and editing persistent files on a disk. True runtime capability is no longer an invisible abstraction inside a neural network. It is a tangible directory you can open and read. For the last 2 years, giving an AI a new skill meant a human engineer sat down, wrote a prompt, wrapped an external tool, and deployed it as a static asset. A fixed library ages the moment it hits production. Deployment traffic shifts, users find new edge cases, and the static tool fails against variations the human engineer didn't anticipate. Recent architectures attack this degradation in different ways. Systems like ADAS search directly through the space of agent source code, while frameworks like AlitaG evolve domain-specific model context protocol tools to keep pace with the workload. This diagram illustrates Memento's distinct departure. On the left, tasks hit a static database and either succeed or fail permanently. On the right, the frozen model converts those failures into mutations of the database itself, continually compiling new executable artifacts. The burden of continuous adaptation moves from the human engineering team directly to the agent's internal error recovery cycle. Think of a chef keeping a running notebook in the kitchen. When a specific dish fails, they do not throw out the entire book. They isolate the exact step that broke, cross it out, and rewrite that single instruction for next time. This visualization maps the 5-node loop: observe, read, act, judge, and write. The system hits a behavioral router. If nothing matches, it drafts a baseline skill. After execution, an LLM evaluates. On failure, the trace forks, edit the existing artifact in place, or synthesize an entirely new node. Every runtime failure becomes an automated unit test, forcing the system to recompile a tighter workflow for the next attempt. When the authors use the word skill, they do not mean a clever prompt string or a saved chain of thought log. This exploded view peels apart the exact repository structure. A skill is an entire folder on disk. It requires a skill.md file containing YAML front matter and markdown instructions, supported by optional bundled Python scripts and reference assets. The runtime uses a lazy loading mechanism. YAML metadata stays loaded in memory for fast routing, but heavier external scripts and detailed specifications execute only on explicit demand. The mutable unit of evolution here is a runnable micropackage. The agent is designing prompt, tool composition, and execution code simultaneously. Scaling this architecture exposes a severe retrieval problem. If your library grows to hundreds of folders, naive lexical search grabs tools based on overlapping keywords, ignoring the actual execution path required. If the system retrieves a summarization tool for a drafting task because they share the word email, the failure loop triggers on the wrong artifact. The agent optimizes the wrong code and internalizes incorrect logic. To prevent this, Memento replaces standard retrieval with a custom behavioral router. They train it via offline reinforcement learning to prioritize how a skill behaves, rather than its embedding proximity or text overlap. This bar chart measures the resulting accuracy. Standard BM25 search achieves a recall at 1 of just 0.32. Upgrading to Qwen 3 embeddings gets you to 0.54. The behavioral router pushes that metric to 0.60. Without a routing layer trained to match exact execution behaviors, the feedback loop feeds on its own noise, and the evolving library collapses. We have to return to the massive 20-point benchmark gains we looked at earlier. The mechanism responsible for those numbers carries a heavy caveat. On the left, scattered tasks produce zero transferability. On the right, structured, repeating categories allow a skill refined on one query to execute perfectly on the next. You see this dependency in library growth. Processing the structured benchmark expands the repository from 5 to 235 skills. The Counterevidence appears when task structure is removed. Placed into a benchmark containing 34,000 diverse, non-repeating skills, Claude's performance drops to 38.4%. That is a mere 3 points above its baseline performance with no skills at all. The agent designs agent architecture actively degrades system performance unless deployed into an environment categorized by highly structured, repeating task families. Memento-Skills operates as metaprogramming without formal semantics. Instead of a deterministic compiler enforcing logic, it relies on probabilistic routing and large language model judges to write and execute code. Integrating this into a production stock requires 4 strict conditions to hold: repetition in the task distribution, mathematically verifiable feedback, behavioral routing, and an absolute validation gate to check the artifacts. If this architectural analysis helps you map the 2026 stack, subscribe to Bearded AI Guy. Drop into the comments and tell me where a self-designing skill library actually fits your workflow. Internal analytics, customer support issue families. I will leave you with a core principle from the Human Architects Framework. Every self-written skill your agent saves to disk is an unreviewed commit. Build the validation layer before you build the evolution loop. See you in the next one.